Hi, I'm Mr. True. Well, part 2 of doing the chain rule when your functions involve trigonometric functions. So we got y equals the tangent of 3x times the sine of 3x. So what do we have here? We have the product rule, which says that to find the derivative of y, we're going to have to take the first factor, multiply it by the derivative of the second factor, and then add that with the derivative of the first factor times that of the second. Plus, our trig functions don't have just a basic x, they have 3x. So we're also going to be involving the chain rule. Okay, so let's get this started. We have got y prime is equal to the tangent of 3x times the derivative with respect to x of the sine of 3x plus the derivative with respect to x of the tangent of 3x times the sine of 3x. Well, okay, so the derivative of the sine function is cosine. The derivative of tangent is secant squared, but we also have some inside functions of 3x. So I'm not going to do the u substitution, but this is going to be our u here and, whoops, here. Okay, so I'll have to do the chain rule as well as the product rule. So we've got the tangent of 3x, the derivative of sine is cosine, so we have the cosine of 3x, so that is the f prime of g there. And now we got to do g prime of x, or the derivative of u. So the derivative of 3x is equal to 3. Plus the derivative of tangent of 3x, that's secant squared. So secant squared of 3x. I do like to wrap my angle up with parentheses because I don't want it to look like it's the cosine of 3x times 3. It's the cosine of 3x. Textbooks don't generally do that. I do like to add those extra parentheses in there because this is going to be a coefficient, not some multiple that goes inside the angle, okay? That's not 3 times x times 3. It's 3 times the cosine of 3x, or 3 times all of that. Now, okay, so anyway, derivative of tangent is secant squared of 3x. Now, that's again, the derivative of the outside function. Now we need to do the derivative of 3x, which is equal to 3 times the sine of 3x. Okay, now at this point, besides moving the 3's out front, again, the difficulty with doing derivatives, especially with trig functions, is you might get an answer that's not in the back of the book, though everything you did is correct. So if your teacher's not expecting this to be a single term and only be in terms of sine and cosine, you might go, well, let's see, I'm going to move the 3 out front, and tangent is sine of 3x over cosine of 3x, and the 3 out front. And here we have the cosine of 3x. Those will cancel out. So you could have as a final answer 3 sine of 3x plus secant squared of 3x. Actually, I should put that 3 out front. And have that as your final answer. However, if your textbook's like mine, you might look in the back, or if you're looking, I use a T-Inspire CAS calculator to check my work. Even though I'm trying to teach this and I'm reviewing it before I teach it and I'm writing notes, I make mistakes just like you guys do. So when I check this, I got a single fraction with only terms of, or only the trig functions of sine and cosine, no secant. So if you want to rewrite this so it's a single fraction, or if your answers in the back of the book only have sines and cosines and you're trying to check your work, then we could have, let's try and make this look different. That wasn't incorrect, let's just make it look different. We, again, have tangent, which is going to be sine over cosine. So we have sine with the 3 out front, 3 sine 3x, cosine 3x, over, again, tangent is sine over cosine, so cosine of 3x. Now again, those will cancel out, but over here we have secant squared, which is 1 over cosine. So we have plus 3 sine of 3x over cosine squared of 3x. Now if I want to write these two fractions together, if I want to make it a single fraction, of course I need common denominators. So I need to multiply the top and bottom of this fraction by cosine to match with the fact that this has cosine squared, or 2 cosines in the denominator. So I'm going to multiply top and bottom by the cosine of 3x, and I don't have a ton of room. So I'm going to say cosine of 3x times cosine of 3x is cosine squared 3x. And of course that's going to get multiplied on the top as well. And that means that we're going to be able to add these two fractions now. So these two fractions have a common denominator of cosine squared of 3x. We can write this as a numerator, except just to show you what my textbook or my CAS calculator showed as a solution. I do actually like the original better, but these two terms both have a sine function and they both have a 3. So if you really wanted to do like a lot of simplification, these two terms you could factor out a 3 sine of 3x. And when you do that, all of this divided by 3 sine of 3x is cosine squared 3x. And then anything divided by itself is equal to 1, so plus 1. So we have our first example done. We have the final answer written in 2 or 3 forms now, as I kind of reworked that and showed you different ways of writing your final answer. So don't believe, or don't have some confidence in yourself. Make sure you follow the rules, of course, and we are learning and we will make mistakes, but have some confidence in yourself that what you've done is correct, and see if you can't make your answer match what's in the back of the book, because we started those skills in pre-calculus when we did our trig proofs, trying to make the two sides of the identities match to prove whatever was given to us. You're just strengthening your algebra skills and your skills with the trig functions that you will use later on in this book anyway. So if you get an answer, you feel like it's right, it's not what's in the back of the book, see if you can't make it match. You're going to use those skills later on in the class anyway. So next example. Woo! Next example, we have f of x is equal to tangent of x over cosine of x. Now, this doesn't really look like we need the chain rule, and if I leave it in this form, which it didn't work out this proof, so I might be speaking incorrectly, but maybe we could do the quotient rule without using the chain rule, because we have the derivative of tangent, which is equal to secant squared, and we have cosine. But if I do it this way, I'm just afraid that bringing in a second power might complicate the material a little bit. Maybe not. If I need my answers to be all in terms of sine and cosine, and I use the derivative of tangent, which is secant squared, then I'll have to make it 1 over cosine squared and maybe find common denominators. I don't really think that it makes a tremendous amount of difference which way you approach this problem, unless, of course, you have specific instructions on how to leave your final answer. But I am trying to, I am looking at the derivative of sine is simply cosine, and the derivative of cosine is negative sine, and there's no powers there to deal with. So we're going to go ahead and make this look a little bit different. If you'd like to leave it or find the derivative in this format, perfectly fine. Give it a shot, see if you get the same answer I do, or if you can make your answer match mine. But we're going to make the sine, the tangent, equal to the sine of x over the cosine of x, and the denominator cosine of x over 1. Now I'm writing it as over 1 because I want to emphasize to you that this middle fraction, this is the one that's right there, is a division symbol, right? So when we divide fractions, we multiply by the reciprocal of the second fraction, or what is always going to be our denominator. So we're going to flip this bottom up, make it 1 over cosine x, and rewrite our function as the sine of x over the cosine squared of x. Let's find the derivative this way and see what we get. So f of x is equal to sine over cosine squared x. That means f prime of x is equal to, now this is the difference rule, so we're going to take the denominator, which is cosine squared, multiply it by the derivative of the numerator, or sine x, minus, now we're going to take the derivative of the numerator, multiply it by the numerator, all over the denominator squared. Now, cosine squared x squared is going to be cosine to the fourth. And let's see here. Depending on how much I fiddle with this problem, I could take up a decent amount of room, and I'm kind of writing rather big for how long this problem is. So let's do some scratch work here as we go. The derivative with respect to sine is cosine. So this is going to come out, and cosine is going to go in its place. The derivative of cosine squared, now that is going to take, let's see here, that's cosine squared. So that means we're going to need to use the general power rule and the chain rule, because it is something being squared and that something is cosine. So the cosine of x is going to be the inside function. So this is going to be, let's just do all that over again, the derivative of the denominator. So the denominator is something squared. So that's going to be 2 times that something. And we're going to reduce the power by 1. I don't really need to write that. So this is my inside function. The cosine function is my inside function. The 2 used to be here. So we need to find the derivative of that inside function. The derivative of cosine is negative sine. So that's my derivative of the denominator times the numerator. Okay, so we have cosine to the third power x minus, negative times negative is positive, so let's try that again, plus 2 sine x times sine times sine is sine squared, times cosine. All over cosine to the fourth. Now my top 2 terms both have a cosine function in them, so I'm going to go ahead and pull that out and have cosine of x times cosine of the third divided by cosine is cosine squared x plus 2 sine squared x all over cosine to the fourth. I'm not wrapping my, cosine square of 4, what? No, it's cosine to the of the fourth, cosine to the fourth power of x. Now, of course, this one, that was good. This one cosine, and we'll cancel with one of these 4 down here, so this is going to cancel out with this cosine to the fourth, leaving me with cosine to the third in the denominator. And unless I'm out of my mind, we are done. So, cosine squared plus 2 cosine squared x over cosine to the third x. I'm kind of tempted to work this with the tangent function and see what we get. Maybe we'll do that. Why not? Bam! Okay, so I braced my problem. I got my final answer that we had. You don't necessarily have to always have your, like I said in the previous problem, you could have multiple versions of the right answer. Why don't you take the quotient rule, find the derivative in this format, and just for practice, see if you can't get to the same answer again. I'm going to step out, give a second, pause the tape. How old am I? Tapes? This is freaking internet. The video, and then come back and show you the solution. So if you'd like to try this, pause it. In just a second, I'll have the solution up here. Woo! Well, look what happened here. We went ahead and found the derivative using the quotient rule. My shoes just slipped up. We've got the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator over the denominator squared. Of course, that's a quotient rule for finding derivatives. We canceled out the cosines because that's 1 over cosine squared. Sine times sine is sine squared. And, well, we got to this answer, which actually is a little bit simpler looking than mine, but why is it different? Did I do it wrong the first time? That is possible, hopefully not by the time I post them to the internet, but no, I did not. So again, using our skills that we learned back in pre-calculus when we studied trig proofs or trigonometric proofs, where you have to make the two sides the identity match with algebra and your trig identities. We've got cosine cubed on the bottom. There's a cosine squared in the numerator, but there's no cosine in this numerator. So the only way that I can see to make sure that my answer matches this answer, in other words, if they're both correct answers, I actually like that one better, it's simpler, is to do some kind of substitution to get that cosine function out of the numerator and see if I can get it to match that one. I'm so glad I stopped to do this one because I was going to move on to my next example. At least that's what I was planning on doing. Well, you remember the Pythagorean Theorems? There was 3 of them, but the one we're going to use is sine squared x plus cosine squared x is equal to 1. Now, if I write this, I want to get rid of the cosine. So if I write this as cosine in terms of sine, and I don't want cosine to be completely alone because this is cosine squared. If I move the sine over to the other side, I get 1 minus sine squared. Oh, so this can come out using this identity, Pythagorean identity, not in this format. I got to move over the sine squared. But if I use that as substitution, we get cosine squared can come out. 1 minus sine squared of x can go in its place. And what do we have? We have negative 1 and positive 2. Well, what's negative 1 and 2? Equal to 1. So this, the first way we did the derivative is 1 plus sine squared x over cosine cubed. So once again, you might have a correct answer, but it might not be in the same format of what's in the back of the book. So use your skills, use your algebra skills, use your knowledge of the Pythagorean identities, the trig identities, to make sure that you can get those to match, because you might have the right answer. Let's do one more example. This stuff is awesome. Okay, last example, and it's going to be a long one. We have y equals the sine of the square root of the cosine of the cotangent of 3x. Now, why am I annoyingly saying of so many times, or that overemphasizing it? Because that means that we have all these trig functions nested inside of each other, and again and again and again. That means we're going to be doing the chain rule again and again and again. So hopefully I don't run out of room, and if not, I'll just erase it and continue. Now, this is a great place for me to, again, emphasize the extra use of parentheses, because you could easily think that this 1/2 applies to the entire trig function, but it's not. It was the sine of the square root. Like, this is the angle, believe it or not, the square root of cosine of. Okay, so when I take the 1/2 out here, we're not going to start off by doing the general power rule where you take the 1/2 and drop it all the way out front, because it's not, there's no parentheses here and here where the entire expression is raised to the 1/2 power. It's the sine of all of that. So, and all of this is going to be my u, at least in the first step. So the derivative of sine is cosine. So we have y prime. The derivative of sine again is cosine. So cosine. Now I'm doing the outside function, and there's many, many inside functions. So it's going to be the cosine of all this. So cosine of, not times, the cosine of cotangent of 3x, 1, 2, 3, 1/2 power. Okay. Now I've got to take, that's the derivative of the outside function. Now I have to take the derivative of the inside function. I'm not going to try and do that all in my head because there's too many steps. So we're just going to write d with respect to the derivative with respect to x of the cosine, cotangent, 3x, 1, 2, 1/2 power. Just trying to make sure I don't make a mistake here. So, because it is a long problem and I don't want to carry it all the way through. Now, I need to find the derivative of this. I'm going to let this sit out here. I'm also going to go ahead and put a set of parentheses around here. So we have y prime, or just, I'm going to drop the y because I'm going to run out of room, I think. We have cosine times the square root, that's the 1/2 here, of cosine, cotangent, 3x, and the derivative of, now this is, all of this is being wrapped up in the power of 1/2, so it's going to be, now I'm taking the derivative, so times 1/2, all of this, to the negative 1/2 power. Now, if I'm using this 1/2, then again, all of this is my d, or my u, excuse me, my inside function. So I've taken my power, I dropped it out front, I reduced my power by 1, but now this is my inside function, so again, I've got the derivative with respect to x of the inside function of cosine of cotangent of 3x. Okay? So now we've got, just so I don't run a huge long line here, we've got the cosine of the square root of the cosine cotangent 3x. Now this 2, it's 1/2, so I'm going to go ahead and drop that 2 in the denominator. This all has a negative power of 1/2. That means it's a square root, you know, it's 1 power of 1 and a square root, but it's negative. So I'm going to drop that to the denominator. So this is that. Cosine, cotangent, keep trying to make my parentheses too early, of 3x. The derivative of cosine is negative sine, so times negative sine, that's here now. So, oh, man, I got another inside function. So the derivative of cosine is negative sine of cotangent of 3x. 1, 2, 3, close that. Now, again, inside function, so the derivative with respect to x of the cotangent of 3x. So now we have the cosine, square root, cosine, cotangent, 3x. I don't really need those extra set of parentheses there. There's a negative here and a sign, so I can go ahead and bring this out front. Oh, no, it's not. That's not, you know, it's so tempting to think this is a sine of x times something. No, it's the sine of cosine. Okay, so that's going to stay there. The derivative of cotangent is negative cosecant squared of 3x. Now this time I'm not going to, do the work again, but this is yet again another inside function. So the derivative of cotangent is negative cosecant squared of 3x, but that is another inside function, and the derivative of 3x is equal to 3. Woo, we got a lot going on here. Now let's see, is there anything I can move up? I think we can say that this is all multiplication, this is all over 1. So we have, let's go ahead and take this negative out front. So we have negative cosine of the square root of the cosine cotangent 3x. This This is your extra credit problem right here. Sine cotangent 3x. And let's see here. Oh, there's another negative. So negative times negative is positive. So that's not going to go away. And we've got a multiple of 3. So let's go ahead and bring that out front. We have the denominator, which I haven't written yet. Can you tell I really don't want to make a mistake on this video and reshoot it? Cosine cotangent 3x. We have, now the cosecant squared is 1 over sine squared. So I'm going to go ahead and bring this sine squared of 3x into the denominator. And I'm pretty sure I am now done. Let's see here. We have negative, or positive, excuse me, 2 sine squared 3x. We've got the square root of cosine cotangent of 3x. On the numerator we have the 3, the cosine, the square root, cosine cotangent of 3x. We have sine of cotangent, whoops, forgot a parentheses. Not that you really need it, but I like to emphasize those angle measurements. Woo! Wow! Hope that helped. As you get to the end of your assignments of finding your derivatives with your trig functions, that maybe this will help you solve some of your harder equations or harder problems here, because how many times do we have to do the chain rule? We did it 3 or 4 times, 4 times. So that was a little bit tricky. Thankfully I didn't make a small little mistake in here I didn't catch. I'm Mr. True. You know what? Time to go do your homework. Bam! Just before I erase this, P.S. Just before I erase this, I was looking at my answer, making sure that, with all this work and me talking, I did not make a mistake. And I want to make sure you realize why these square roots do not cancel out. Because we do see the cosine, or the square root of the cosine cotangent of 3x, the square root of the cosine cotangent of 3x. Why don't these just cancel out? Because all of this is getting multiplied together, and while you cannot cancel terms, that's things that are being added or subtracted together, you can cancel factors. So why am I not canceling these out? Because this is not, again, cosine times this, it's the cosine of this, okay? This is inside the cosine function, whereas in the denominator, because of the chain rule, it was up here, it came out and it was just, it fell out as its own entity with the negative square root and came into the denominator. This is 2 times the cosine, square root of cosine cotangent of 3x, whereas up here it is the cosine of. So those are not factors that will not cancel out. Now, I'm done.